একটু প্রবলেম হচ্ছে, কানেক্ট প্রবলেম হচ্ছে একটু। রিসোর্স পার্সনের সঙ্গে কন্ট্যাক্ট করা যাচ্ছে না, একটু প্রবলেম হচ্ছে।
হ্যাঁ ইন্দ্রজিৎ বাবু, হ্যালো, শোনা যাচ্ছে?
হ্যাঁ হ্যাঁ, রিসোর্স পার্সন জয়েন করলেন এইমাত্র।
আচ্ছা আচ্ছা আচ্ছা, হ্যাঁ এবার শুরু করুন। হ্যাঁ ইন্দ্রজিৎ বাবু, হ্যালো, শোনা যাচ্ছে?
হ্যাঁ হ্যাঁ, রিসোর্স পার্সন জয়েন করলেন এইমাত্র।
আচ্ছা আচ্ছা আচ্ছা। Hello, am I audible?
Yes, yes, you are audible.
So now let's start. As a students of geography, we have learned that Earth is dynamic, not static. Scientists say the present physical condition of Earth is too much differ from its earlier, or it when it was originated. They say that present condition of Earth is the result of long changing process or evolution process, and the process is now continued. The three main elements of Earth, such as atmosphere, lithosphere, and hydrosphere, all are involved with this evolution process. When we discuss the evolution process in our hydrology, we may found several factors or indicators which are modified our hydrosphere and also affect our lithosphere and our atmosphere. Within these factors or indicator, sea level is very important. Yes, today we will discuss on the topic sea level, basically sea level change. Good afternoon all. Today, Department of Geography of Sitananda College in collaboration with NSS Unit 1, 2 and 3 Sitananda College has organized a national level webinar on the topic sea level change. In this special occasion, I like to welcome our Honorable Chief Patron, Dr. Sabu Mahali, Principal, Sitananda College. Then I welcome to our eminent resource person, Dr. Sumanto Dandapat, Assistant Professor in Geography. Then I welcome to our faculty member of various departments of our college and also other institutions. And I also welcome to our beloved students and other participants. Today, in this webinar, we will discuss on the topic sea level change, and our eminent research person, Dr. Sumanto Dandapat, will deliver his valuable speech on the following topic. Dr. Dandapat is an assistant professor of Department Geography in Shivaji University, Kolhapur, Maharashtra. His academic and work and research experience is so glorious. He completed his PhD in geography from Benares Hindu University and achieved Geeta Mukhopadhyay Best PhD Thesis Award for the year 2017 by CSIR National Institute of Oceanography. He presents many research articles in several national and international journals and also reviewer some journal. His area of interest basically oceanography. So we are waiting for his valuable speech on the topic, and I am sure it will be very much knowledgeable and informative to the all listeners. Now, I like to request to our respected Chief Patron, Dr. Samu Mahalik, Principal, Sitananda College, to deliver the introductory speech for the webinar. Please, sir, Dr. Samu Mahalik.
Thanks. Good afternoon to all. Good afternoon to one and all present. I feel honored to welcome all of you to today's webinar on sea level change on 24 September 2022 on the occasion of Azadi Ka Amrit Mahotsav, is organized by Department of Geography, Sitananda College, Nandigram, in association with all the NSS units of Sitananda College, Nandigram. I would like to convey my sincere gratitude and thanks to our eminent speaker, Professor Dr. Shumanto Dondapat, Department of Geography, University of Shivaji University. I hope that he will enrich with knowledge after completion of his valuable lecture in the field of sea level change or sea level rise or in the given topic. It gives me immense pleasure in welcoming all of you to the webinar, both the conveners and all the members of NSS units, mainly conveners of Department of Geography and the NSS unit of my college has organized with a vision to serve and share the knowledge to the student and the scholars, research scholars, and the society. We focus more on sea level rise, especially in the coastal area, and more especially in the coastal area of Bay of Bengal. Thus, it will earnestly improve the knowledge of the students and others participants. Well-known experts, researchers, and students from the different universities, colleges, and other institutions and societies have been invited to present their views and to know different type of all important idea regarding the sea level change and discuss of the core subject matter. I hope you have an engaging and enriching session ahead. Today's topic is sea level change, especially sea level rise. Being a student of geographer, this is the very burning topic, and not only the student of geography, for all, this is the sensitive and so important and burning topic for us. because many of the scientists are forecasting that after 25 years, especially in the eastern coast of the West Bengal, about the 10 crores people will be displaced. Anyway, here I want to discuss about the sea level change. What is the sea level change and how it is occur in the maritime area, in the hydrosphere or in the ocean area. Global sea level are rising as a result of human-caused global warming, with recent rates being unprecedented over the past 2,500 plus years. Sea level rise is caused primarily by two factors related to global warming: the added water from melting ice sheet and glacier, and the expansion of seawater as it warms. Here I want to discuss about the global warming. The added of water from melting ice and the expansion of the oceanic water, both are main thing for the rising of the sea level. The rate of global sea level rise is accelerating. It has more than doubled from 0.06 inches per year. Average sea level has risen at the rate of 0.12 to 0.14 inches per year. Relative sea level rose along much of the coastal area of West Bengal is 8 inches. Relative sea level rise is not uniformly because of regional and local changes in land movement also, and long-term changes in coastal circulation pattern and climate change also. Changing sea level can affect human activity. All sort of activities will be affected by the changing sea level, mainly in the coastal area of whole world. One example here I want to put or give for the student. My teacher of Vishwabharati, respected Professor Dr. GPC Guru Prasad Chatterjee, once he was the researcher, principal researcher of Government of India in the Department of Glacier Melting Department. Once he depicted that about 250 glaciers are there in Jammu and Kashmir, but now about 80% glaciers are not in existence due to global warming. Out of 250, only 25 glaciers are there. We can imagine how rapidly all the glaciers are melting and extincting due to global warming, and due to this cause, each and everywhere sea level are rising. In Pakistan, maximum glaciers are there. Among the world, Pakistan has maximum glacier in the world. But now, none of this, no any glacier is there. And not only sea level rise, not only the cause of, not only the main cause of global warming. Many causes are involved behind the sea level rise. Geotectonic activities are also involved, and deposition of the loads like sand, soil, and other particles in the river mouth or in the oceans are also responsible. But principal cause for the sea level rise is the global warming, and main cause is the human activities. Some scientists are forecasting or oracling that by 2050, only in West Bengal, in the coastal area of West Bengal means, I mean to say, from the river mouth of Suvarnekha to the river mouth of river Ganga, about 400 kilometers long. In this area, about 10 lakhs people are residing. After the 2050, all the peoples, all the inhabitants, all the domiciles will be naturally displaced. And that time, the challenging problems among the government and the other local people about the displacement of the 10 crore people. And some scientists are saying that after 10 years, that size of that 10 crore people will increase up to 20 crore people. And that time, all the agricultural land of this area will be submerged. Here, for the my student, I want to say in Bengali that আমাদের এই এলাকাতে বিশেষ করে এই পশ্চিমবঙ্গের উপকূল অঞ্চলে আমি যেটা একটু আগে ডিফাইন করলাম যে সুন্দরবন অঞ্চল থেকে উড়িষ্যা উপকূল বর্ডার অর্থাৎ সুবর্ণরেখার মোহানা পর্যন্ত প্রায় 400 কিলোমিটার অঞ্চল, এই এলাকাতে কলকাতা থেকে এই এলাকাতে প্রায় 10 কোটি লোক বসবাস করে। তো নাসার কিছু সায়েন্টিস্ট এবং আমাদের যারা জিওলজিস্টরা রয়েছে এবং গভর্নমেন্ট অফ ইন্ডিয়ার জিওলজিস্টরা যারা রয়েছে, ওদের রিসার্চের মধ্য দিয়ে এটাই বেরিয়েছে কি এই এলাকাতে যে 10 কোটি লোকজন রয়েছে ওদের আর 25-30 বছরের মধ্যে এখান থেকে ডিসপ্লেসমেন্ট হতেই হবে। এই এলাকাতে প্রায় 4 মিটার অবধি জল হয়তো সি লেভেল যে লেয়ারটা উঠে আসবে। আমি প্রথমেই বলে দিয়েছি সি লেভেলের লেয়ারটা দিস ইজ রিজনাল। অনেকে জায়গায় এমন আছে সি লেভেলের লেয়ারটা হয়তো নিচে নেমে যাচ্ছে, অনেকে জায়গায় এমন আছে হয়তো সি লেভেলের লেয়ারটা হয়তো অনেক উঁচুতে চলে যাচ্ছে। যেমন আমাদের কলকাতা এরিয়াতে, দমদম এরিয়াতে, ওখানে সি লেভেল হয়তো বিলো 4 মিটার, হয়তো আমাদের এই কোনটা এরিয়াতে 11 মিটার, আমাদের এই নন্দীগ্রামে 4 মিটার, বা এই খেজুরি কাছাকাছিতে 4 মিটার। তাহলে এই এলাকাগুলোতে খুব দ্রুতই আমাদের সমুদ্র তলায় হয়তো চলে আসতে পারে। আমাদের একটা স্যাটেলাইট ইমেজের ভিত্তিতে একটা ডেটা দিয়েছে, যেমন পুরো এটা গ্লোবাল, পুরো বিশ্বের ভিত্তিতে 1900 থেকে 2020 মধ্যে প্রায় 200 মিলিমিটার সমুদ্র জলস্তর উঠেছে। 200 মিলিমিটার আই মিন প্রায় 8 ইঞ্চির মতো, 7.86 ইঞ্চি হয়, সেটা পুরো গ্লোবাল স্তর। কিন্তু রিজনালি আমাদের এই ওয়েস্ট বেঙ্গলের কোস্টাল এরিয়াতে আরো বেশি হয়তো প্রভাবিত হবে এবং উচ্চতাও অনেক বেশি বাড়বে। তো যখনই আমাদের এই এলাকাতে যেমন এত লোক হয়তো বেড়ে যাচ্ছে বা ডিসপ্লেসমেন্ট হয়ে যাচ্ছে, তখন ওই আবার এই এলাকা যে কৃষি জমি রয়েছে পুরো জলের তলায় চলে আসবে। তখনই আমাদের ওই খাবার দাবার বিরাট অভাব হবে। তখন আমাদের এখানে পপুলেশনের সাইজ প্রায় 20 কোটি হয়ে যাবে। 20 কোটি লোকের খাওয়া দাওয়ার জন্য বা বসবাস করার জন্য তখন জায়গাও থাকবে। তো যাই হোক, এই ধরনের এই যে প্রবলেমটা হুট করে এখন হচ্ছে না, দিস ইজ নট এ ম্যাজিক্যাল প্রবলেম অর মিউজিক্যাল অ্যাক্টিভিটিস। এটা বহু সময় লেগেছে, আমরাই বহু অ্যাক্টিভিটি করেছি মানুষের, হয়তো ইন্ডাস্ট্রিয়ালাইজেশনের জন্য বা পপুলেশন গ্রোথের জন্য বা বৃক্ষচ্ছেদনের জন্য বা বিভিন্ন কারণে হয়তো আমরা পৃথিবীকে উষ্ণায়ন করেছি, পৃথিবীর উষ্ণতা বেড়েছে, যার ফলে এই ঘটনা এখন দেখতে পাচ্ছি। আমাদের ওই ডিসকভারি চ্যানেলগুলোতে হয়তো দেখলে ভয় লাগে মাঝে মাঝে, এই যে উত্তর মেরু দক্ষিণ মেরুতে যেভাবে বরফ গলে যাচ্ছে, ওগুলো দেখে ভীষণ ভাবে ভয় লাগে। গলে যাওয়ার পর সেটা তো বরফ জল তো জলের মধ্যে পরিণত হয়ে যাচ্ছে, এবং ওই যে জল এর মধ্যে টেম্পারেচার বেড়ে গেলে সেটা এক্সপেনশন হয়, প্রসার, যার ফলে দুটো যে কারণ রয়েছে, এটাই মেন কারণ সমুদ্র জলস্তর উত্থানের জন্য। এবং আমাদের এই যে মানবের সভ্যতা যেটা রয়েছে, ওই মানব সভ্যতাটা হয়তো কিছু এলাকাতে ডিস্ট্রাকটিভ চেঞ্জ হবে। যেমন দুটো থটের দিক থেকে দুটো কনসেপ্ট রয়েছে, পসিবিলিজম এন্ড ডিটারমিনেশন। তো এই যে কনসেপ্টটা রয়েছে ডিটারমিনেশন, যেটা আমেরিকার জিওগ্রাফার হয়তো কুমারী স্যাম্পল ইনি হয়তো আবিষ্কার করেছে। যেমন আমাদের এই যে তমলুক অব্দি সমুদ্র বন্দর ছিল, তো বিজ্ঞানীদের কিছু বিজ্ঞানীদের মত অনুসারে পুনরায় আমাদের এই যে সমুদ্র তমলুক অব্দি চলে যেতে পারে, নট অনেকদিন, কিছু দিনের মধ্যে 2050, নাও ইট ইজ রানিং 2020, মানে আর বেশি দিন নেই। তো এই সমস্যাটা বিরাট বার্নিং ইস্যু। তো যাই হোক, আমি হয়তো টেকনিক্যালি সেশনের দিকে বেশি বলতে চাইছি না। আই ডোন্ট ওয়ান্ট টু prolong and don't want to discuss on technical matter, because being a geographer, many things are there. Now our future generation have to take a step for the prevention. Taking a step means plantation and other sort of precaution measures are there. All sort of precaution measures we have to maintain. Otherwise, we will see in near future, very recently we will see after near future, we will submerge, especially in Nandigram, Kejuri, and all the coastal area of West Bengal. I hope that you have an engaging and enriching session ahead. Again, thanks to my resource person, he is a very eminent and a scholar in the field of hydrology and maritimes, in the field of oceanography. He will enrich our student and research person. I don't waste my time. I am waiting for his lecture. I welcome all of you once again to the webinar and hope that you all will have a great time ahead. Thanks to all. Ranjan. Hello, Ranjan Babu.
Thank you, sir.
Continue your program.
Thank you, sir, for your informative speech in this webinar. Your speech will enrich me and also other participants. And now, without losing any time, I request to our respected resource person, Dr. Sumanto Dondopat, to deliver his valuable speech. Dr. Bandyopadhyay, please continue.
Should I start? Hello.
Yes.
Yeah, am I audible? My audio is clear, no?
Yes. Yes.
Introducing me, and also thanks to the organizing team for giving me the opportunity for or to interact with students, particularly of this college, and also some faculty members who have joined this. Can I start my presentation?
Yes.
Hello?
Yes. Yes. Please continue.
Okay. Okay. Yeah, can you see the presentation
Yes, yes,
on your screen?
yes.
Okay. As sir already told you that today's theme is sea level change. Particularly, I'll be focusing on the types, causes, and consequences of sea level change. My major focus on this lecture will be global change, and also later on I will come to the consequences and regional perspective of these sea level changes. Before I start, I think all of you are aware about the distributions of water, or what we call it as the movement of water and the storage of water in different places. Mostly, as we all are knowing, that the water mostly are placed in the oceans or seas. So saline water contribute mostly 97.5%, and the remaining water the fresh water, 2.5%. Out of the 2.5%, the glaciers and the groundwater, they take up the maximum pile, say roughly around 95 to 98% only in the glaciers and groundwater. Remaining water only there in permafrost, freshwater lakes, atmosphere, soil moisture, biota, etc. So most of the water are saline water, and out of the fresh water, only glaciers and groundwater the major contributing factors. So they can influence the global change. Other things like river water, like say atmospheric water, they though they are dynamic, but they does not contribute much in the storage capacity or the storing of the water in that particular regions. Now, again, another interesting thing is dynamic topography of the Earth's surface. I would like to share here that perhaps all of you have learned about the plate tectonics, particularly geography students who are there. Mostly, I think participants are from geography background. So I expect that you know about the dynamic surface, mostly about the plate tectonics, which is responsible for say movement of the plates or the continents or the oceanic region also. So here, the one thing I would like to highlight, that the speed of the movements, or you can say mostly we see the mid-oceanic ridge system here. You see the lines here. Can you see it? Middle part of Atlantic oceans. Even most of the time you will find these mid-oceanic ridge systems in the middle, and sometimes you will find in maybe near the coast also. The speed of change or new earth crust creations in Atlantic oceans and in Pacific Ocean, they are not same rate. They are not at the same rate. Here the rate is specified in centimeter per year. So in Atlantic Ocean, you see here, the average speed is 2 to 4 centimeter per year. So average speed at which new land masses are being created is 2 to 4 centimeter per year. And here in Pacific Oceans, particularly in the Eastern Pacific near Peru, Chile, and these regions, here the average speed comes out about 13 to 14 centimeter per year. So the speed at which the new land masses are being created in the oceanic base or say floor, these also vary in every oceans, not particularly in Atlantic or Pacific, even in Indian Oceans also. Even within the Indian Oceans, the place-wise it's vary. Somewhere it may be 1 centimeter, somewhere it may be 3 centimeter. And similarly, there are some zones where we have destructions of the land masses, and which is particularly responsible for the mountain building process, and that speed also vary. So place-wise, the new land masses creation and destructions also vary. Mostly you will find the red marks here, they have a higher rate, and purple and green color sets indicate they have a lower rate. On an overall basis, you can say Atlantic Oceans has a lower rate of new land masses creation, and Pacific Ocean has a higher rate of new land masses creation as well as destructions. Both happens simultaneously. Now, what is sea level? What do you understand about sea level? Normally, sea level, we call it as sea level if it is the base level. Base level here means the reference datum. Normally, whatever elevation we call it at, say for example, this Kolhapur is maybe placed at a elevation of 500 meters. So these 500 meters normally calculated from the datum. Datum here is sea level, that is the mean sea level. See, even sea level also fluctuating. I mean, within the daytime, if you visit in the morning and if you go to the midday time and evening time, every time the sea level may not be at same places. They may be varying a few centimeters or maybe some places few meters. So this base level or the reference datum for measuring the elevation and depth, not only elevations, even the depth when we measure, like for example, Mariana Trench is deeper, more than 11 this kilometer. So this way, the measurement of elevation and the measurement of depth are normally counted from the datum, that is the reference level we call it as mean sea level. Even the mean sea level picture is not always same. Means every country had different perspective of calculating these mean sea level figures. And this mean sea level, normally the height of the ocean surface at any given locations or sea level is measured with respective to either the relative sea level or the local variations, and also perspective to the, say, from the center of the earth. So you have a reference ellipsoid on that basis also. We call it as regional or relative sea level for local perspective, and we can call it as geocentric sea level if we calculate it from the center of the earth locations. Okay, now we'll discuss about the types of sea level changes. So what we call it sea level change, there are different types of sea level change. Primarily, the major one, we call it this global change. Normally, global change are contributed because of the this global adjustment of the volume of water. Means sea level can rise or fall because of either addition or removal of water from the ocean basins. And also, it can be changed because of the change in the size of the container. Container means here the ocean basins. So, what I meant to say that where the water is placed. So, ocean basin is there where the water is placed. If the size of the ocean basins vary, then obviously water will fluctuate. It can go up, it can go down. So the first one is eustatic sea level change is referred, basically the global adjustment in the total volume of seawater obtained within the ocean basins. So if the global adjustment happens, then we call it as eustatic sea level change. Mostly this is because of the glaciation and deglaciation, this process. Glaciation means new glaciers additions or new ice additions in the land masses, and deglaciations means melting of the ice from that glaciers, not only glaciers, even in the ice sheets or ice shelves, etc. Then isostatic sea level change is basically the result of the either upliftment or depressions. So it can cause more pressure or release of the pressures. So either you can say loading of the earth crust and unloading of the earth crust. Normally it has a localized effect, but not a particular smaller location. It can impact a larger area. So we call it as regional level change. So isostatic sea level change normally happens because of loading. Loading at what thing that can cause loading? For example, you have more ice in particularly winter seasons, more ice formations and more snowfall happening in particular places. So that can cause more weight to there at that location, so that can cause the depression of that land surface. So this way it can be depressed. Whenever melting happens, it can release the weight, so therefore it can come upwards. So either loading or the reductions of weight can create the rebounding of the earth. The third one factors, that is tectonic sea level change. This can happen because of the tectonic movement of the earth surface or earth crust. Tectonic movement, particularly we know that plate tectonics are behind this, and this is mostly happen in the seismically active regions where more faulting, more folding are taking place. So this is a particularly local area affected by this tectonic sea levels. Out of these three, the smaller area impacted by tectonic, relatively larger area impacted by isostatic, and a global adjustment happens in eustatic case. So we have local change and global change. Now, as I have said, the concept of relative sea level and geocentric sea level. Relative sea level normally we can calculate or you can estimate based on the seasonal changes, or say for example some few years, maybe the coastline at or the shoreline at Digha or maybe Bhajar, they may be going upwards or downwards relatively to reference from maybe some buildings are there or some major point is there. So based on that you can calculate it is going up or down. So this is relative change happening. And geocentric, as I have said, this is calculated from the center of the earth. So this calculation normally uniformly can be applied everywhere throughout the world. Okay. And there are some other factors which can contribute, mostly in volumetric measures, groundwater and ice sheets, melting and additions. There are some other processes which can cause, other processes I mean to say that there are some major processes and minor processes which contribute to these changes. First, for example, glaciation, and you can add it as deglaciation also, because glaciation means ice formation, deglaciation means ice melting. This can cause of change 1 to 15 millimeter per year. Means it has a capacity to change 1 millimeter per year to 50 millimeter per year at current perspectives. And this normally change the water volume. So either it can, as I have said, the change can happen because of basin size changes or because of volume of water changes in the ocean basins. So glaciation normally impact the water volume. So this way, if glaciation happens, it remove water. If deglaciation happens, it add the waters. And the second factor is glacial isostasy. Mostly isostasy is related to the glaciers because mostly you see in Antarctic continent, here the loading of happens because of more ice formation during winters, and unloading happens during summer, and this can cause sea level to rise about 0.5 to 5 millimeter per year. So this is again rate of change, about 1/3 of the rate of change that impact by glaciation, impacted by the glaciation or deglaciation. So isostasy has a capacity, it can rise sea level of about this much, 0.5 to 5 millimeter per year. Normally happens wherever you have loading because of the more glacier, more ice formations. Then the other minor factors which also contribute to the sea level change are the self-margin sinks and rise. So you have margin area mostly in the continental shelf and slope areas where you can have some addition of the sediments or maybe some tectonic movement there. So self-margin sinks or rise can also impact. Change in rate of spreading, as I have said, the rate of sea floor spreading is not constant everywhere, it is changing, and also this change within the same locations can maybe fluctuating this trend can also impact the sea level at that places or maybe surrounding places. And other factors like sediment transfer to the oceans, this is a unidirectional, mostly sediment through rivers, they comes from the land area towards the sea, so they are unidirectional. Erosion materials goes to the oceans. Then sediment, you have juvenile water, this is normally we refer this term for a new water addition. So if the new water comes from anywhere, we can call it as juvenile water, so which was not part of the hydrosphere previously. So we call it as juvenile water. This water addition can also impact the sea level. Then subduction area, they have subduction zone, so their tectonic processes can also impact the removal of the sediments or the addition of the sediments in land or oceans. Change in water temperature, though here it is specified as slow, but this is not actually slow. Nowadays, scientists has found that this change in water temperature has a larger impact than many of the themes which are specified here. Even eventually, after maybe 100 years, 200 years, this factor will be the primary contributor to the sea level change than the current one. Current, maybe you can say glaciation and deglaciation, the primary factors, and this is the secondary factors. But after some times, maybe a few 100 years, this will be the primary factors if that happens. So these are some of the major factors and some of the minor factors which are contributing to this sea level change. Hello.
Yes.
Yeah. This is visible now.
Yes. Yes.
Okay.
I request Dr. Dandapat, if you don't mind,
Yes.
will you deliver your speech in Bengali?
I will try. I will.
Because some student here, they will understand your valuable speech.
Okay, I will go slow and I will try. If it is possible, then I will try to speak in Bengali also.
Okay,
I understand
okay.
Bengali, and thank you, Ranjan. Ranjan is my classmate. Was my classmate during my graduation time, and also I know Bengali. So yeah, but actually, what happens? We do not speak in Bengali here, so my Bengali may not be good in academic sense. So I will try my best.
Okay.
But if you have any queries now, sorry.
If possible,
Yeah,
not
okay.
force.
Okay. Thank you.
Thank you.
So sea level change during the past, মানে sea level এর যে পরিবর্তন হয়েছে past, I mean to say recent past here particularly. Sorry, Bengali is not coming from my inside. So I'll later on in discussion part now I will speak in Bengali. Okay? Is that okay? I will go slow in English and later on I'll speak in Bengali also for means summarizing these things, whole things.
Okay. Thank you. Please continue.
So sea level change during the past, particularly the recent past, if you visit to the last, say 250,000 years from present date, we have seen that sea level has never been constant. It's always dynamic. Means the sea level from now onwards, if you go maybe 15,000 years from today's date, you will see sea level was maybe about 120 to 130 meters below the current level. 130 meter is not little bit, 130 meter, not about the distance from the coast shoreline to 130 meter. It is about the depth of the water. Depth of what 30 meter at your place, maybe near to Digha, it will cost you about 100 kilometer away. So you can imagine that 15,000 years before today's date, the sea level was 100 kilometer away from the present days. Means now you will find sea level near Digha or near Haldia port, but it was 100 kilometer, roughly around 100 kilometer away from that place. So you have more 100 kilometer land area, not only in your place only, everywhere this much addition will be there. So last 15,000 years, you can imagine it. Say for example, during Ashoka periods, that is roughly around 2,500 years from today's date. If you divide it, so it was roughly around say 5 kilometer to 10 kilometer away from the coastline, current date coastline. So this way you can extrapolate it up to 15,000 years. Or exactly, if you come to the deepest point, you can go up to 18,000 years from today's date. It will be roughly 125 to 30 meter in Indian perspective. In India ke sense mein you will find this much depth for the sea level from current date. And also not only here, some point of time we have seen that the sea level was much above the to present date, the level what we are experiencing now. So level was most often you will find it was lower than current. And some point of time we have seen that sea level was higher than little bit higher than the current level what we have seen. And if you see last 2 lakh years, 2,50,000 years, most of the time the average sea level was roughly 50 meter below the current level, and 50 meter depth wise. It means distance wise it will cover roughly around 50 kilometers, so 40 to 50 kilometers away from the coastlines. This is one interesting data point I would like to highlight here. And what the past records suggest means based on the proxies. Proxy mean there are different ways scientists collect the records of the past history. So these proxies given us some idea about some particularly at say one intervals during Middle Pliocene, that was maybe 3 million years from today's date, where the temperature was 2 degree to 3.5 degree centigrade warmer than the current date. Current date I mean to say here pre-industrial temperature, global average temperature. That time it has experienced 2 to 3.5 degree centigrade more temperature globally. So that time what was the sea level? They have seen that sea level was maybe at same places little bit higher, and also this higher rate not always constant everywhere. Means every places, as I think Principal Sir already told you, that all places has not experienced rise or fall similarly or similar volume or similar amount. Some places may have risen, some places may have fallen because of local factors, maybe tectonic factors like some faulting taking place. So coastline has raised. So this way they may be looking that area, the sea level has fallen. So what they have seen, these Middle Pliocene periods, particularly in Antarctic, near the Antarctica, you have Eastern Antarctic and Western Antarctic. Even in both area, they are not behave simultaneously or similarly. Eastern Antarctic has a different behavior, and the Western Antarctic and Greenland ice sheet have behaved differently. The maximum estimate shows that it may be about 20 meter from the current rate, current sea level what we have nowadays having. So if you can extrapolate this 20 meter rise from current rate, that will cover a huge land area. 20 meter means many hundreds of crores of people will be impacted where they are living now. Even West Bengal, I think almost 1/3 of West Bengal will be vanished if the 20 meter rise of sea level happens at maybe 200 meters, 500 years down the line. Now, what is the current rate of sea level rise? If you keep the global average, it may be coming about 3.5 to 3.6 millimeter per year worldwide. And also these measurements, if you count this different scale or different point of time perspectives, then it will give you different pictures. For example, in 2020, the global sea level has risen about from the 1993 level to 91.3 millimeters. So about 10 centimeter rise in last 30 years. 10 centimeters, I mean to say, you have most of I think all of you are using the scale for practical geography. So you have 15 centimeter scale. Now you can imagine how much rise has happened in 30 years. 30 years means your age may be around 16 to 20 years. So these 20 years, we have experienced roughly 7 to 8 centimeter rise of sea level. So half of that scale, this much water has risen. And this rate is not steady rate or constant rate. It is accelerating rate. Earlier it used to be lower rate, and now it is a relatively higher rate compared to the previous time. So if you go back, means before 2000, before 1900 year, so rate was much lower than the current rate. So, sorry. Hello.
Yes.
Yeah. Okay. I thought I got disconnected.
No.
Okay. Anyway, so the major factors here is greenhouse gases, which is causing the global warming. As Sir already told you, the global warming is a primary factor for all these changes, or we can call it as climate change as a primary factor for all these sea level changes. And climate change normally responded by the greenhouse gases, response of the greenhouse gases. I think most of you are knowing about the greenhouse gases, name of these gases, primarily CO2 and other gases, which are there, and our contribution, means human contribution to these greenhouse gases directly impacted the sea level rise, which we are experiencing nowadays. Higher emission can cause speedy increase, and lower emission can cause steady increase of sea level. And sea level has risen about 8 to 9 inches since 1880. This 1880 is a time from when onwards we have instrumental record to have the change in temperature, change in precipitations, change in say tidal gauge, or we call it as sea level change. Means actual record happens to be counted or recorded from this time. So from this time also we have experienced this much changes of the sea level. And some of the research based on satellite observations and based on tidal gauge, based on normal things, means what are the way people used to be measuring the sea level, they have also experienced that the trend is rising. Earlier it used to be 1.5 millimeter per year, then increased to 1.7 millimeter per year, now increased to 3.3 millimeter per year, and now 3.6 millimeter per year. So every year down the line, we have increasing trend of sea level rise happening. And this is the current data. You can see, say rate is here. I think this is last year data. 93 onwards, the average comes out to be 3.4 millimeter per year. And this is the trend here. You see the graph. And also you can see in between some year, we have falling sea level. So not always it is steadily increasing every year by year, but on an average basis, it is increasing. So it may be possible that next year sea level will fall a few centimeters, few millimeters. So this way it can happen. But overall basis, the trend is towards high. And earlier we used to be measuring using tide gauge, and now we have satellite investigations or satellite observation also, which can give you clear pictures about the sea level rise. Now, inconsistency in change of sea level. Most of the time, nowadays we deploy the satellite measurements using satellite systems or remote sensing. We calculate the sea levels, mostly geocentric sea level. That shows the rate of geocentric sea level change around the world is not same. For example, in the Western Pacific Oceans, rates were 3 times greater than the global mean values, about 3 millimeter per year. So, যতটা গ্লোবাল ভ্যালুর চেঞ্জ দেখা যাচ্ছে তার থেকে অনেক বেশি চেঞ্জ দেখা যাচ্ছে প্যাসিফিক ওশেনস, একটা পার্টিকুলার ইস্টার্ন প্যাসিফিক ওশেনস, and also ocean Pacific part of the Pacific oceans. In contrast, those in the Eastern Pacific oceans are lower than the global mean values, and some of the places, particularly the ocean coast of America, they have seen the rise or falling of the sea level in the local perspective. So at the same time, where globally we have seen the rising sea level, at some places the sea level is falling. Now will come what are the things or that causing these rising and falling at different places at the same time. This picture can give you outline. For example, this is a global map, particularly focusing on the Pacific Oceans. These Pacific Oceans, the western side of the Pacific Oceans, you see, this is the area. Most of the time you have change of sea level in positive directions, means rising on the sea level. And here in this sides, you will see change in sea level in negative sense means falling of sea level at these locations and these locations. Even in the same coastline, South America, you have some places rising, some places falling. So as said, already told you, the place-wise it also vary. Regional scenario may be different than the global scenario. Now, what are the contributors to sea level rise and current perspectives? So earlier it used to be the added water, mostly melt water coming from the melting of snow or ice or glaciers. And nowadays, the major addition is thermal expansion. You see, from year 2002, 2010, the thermal expansion is not contributing. But from 2012 onwards, you see this thermal expansion causing about 4 centimeter rise of sea level from 2012 to 2018. These 6 years has caused roughly around 3 centimeter rise of sea level happens only because of thermal expansion. Thermal expansion, what it is? Means normally you know that whenever water is warm up or they receive more temperature, they expand. So जैसे आप मतलब you know the ocean has roughly about 4 kilometer deeper water. So if the rising of temperature happens, rising normally happens at the top layer, maybe 200 meter, 300 meter at the surface of the oceans. This rising, the addition of more temperature can cause inflation of the level of the water. So mostly thermal expansion can cause sea level rise, and eventually they add up with the melt water. Together, this is the amount what we have seen, the trend of sea level rise from 1990s to 2020. So this is in centimeter graph. This is the trend. And the primary factor for thermal expansion is ocean heat content. And the data suggests from 1955 that this is the amount of joules or amount of heat being stored in the oceans. Cumulatively, they are added up. So this is the amount of heat that being added up in the oceans, which is causing the thermal expansion to increase or to happen. Now come the major slide here. Different thing or different theme which have impact on the sea level change. Some processes, some storage, and some dynamics which can cause sea level to rise and fall. Before I speak about anything, I mean to say what are the maximum level we can expect the sea level to rise. মানে কতটা সি লেভেল উপরে উঠতে পারে যদি মনে করা যায় যে সবকিছু সমস্ত আইস সমস্ত বরফ যা আছে বিভিন্ন পাহাড়ে বা আন্টার্কটিকাতে বা গ্রিনল্যান্ডে যদি সবকিছু মেল্ট হয়ে যায় তো ম্যাক্সিমাম কত দূর অবধি সি লেভেল উঠতে পারে যদি সেটার দিকে দেখি তো you will find that Antarctica ice sheet itself can contribute up to 58 meter only to the volume of water, not including the thermal expansions. So in volume of water, if all of the ice in the Antarctica they melt up, then they can that itself can cause rise of 58 meter sea level from today's date. 58 meter means you can imagine that almost 60% of West Bengal, 60% land area of West Bengal are lying below 58 meter height or altitudes. This way you imagine what will be the future. If that happens, so your place like Nandigram, Haldia, Kolkata, they will be vanished. Only if the Antarctica ice sheets melt up. Now add it with Greenland ice sheet, which has a capacity of 7 meter. Mean Greenland ice sheet itself can contribute 7 meter rise of sea level. And glaciers, particularly the mountain glaciers here, that contribute 0.5 meter. Though it looks like minimum 0.5 is not much like in comparison to 58 meter or 7 meter, but the factor here, this is the more dynamic than Antarctica and Greenland. So these mountain glaciers are more responsive to the temperature change than Antarctica and Greenland at today's state perspective. So every year you have snowfall and you have melting of ice in the Himalaya, in other mountain peaks. Now the processes which are there, which are responsible, you have gravitational pull-up of ice that can pull the ice from the mountain towards sea, hydrological cycle which can cause more evaporation to happen and more snowfall happens in the land area, and opposite reverse it can act. Then wind can cause local rise of sea level. For example, if wind is blowing toward this side, you can experience this side sea level higher than this sides, because wind is coming from this side toward this side. So this way, the wind can carry a substantial rise of sea level toward in these directions than this area. Then you have currents. Sometimes oceanic currents, as you have learned, the oceanic current can carry the water from one place to another place. This, to some extent, can rise the sea level. Then you have river runoff, sedimentation or erosion. You have groundwater addition or removal from the sea, subsidence that can, as the container size changes, etc. And basal melting, surface melting, calving means whichever ice is there in the land attached to the land area, they can melt up and mix up with the oceanic area. That can cause the more rise of the sea level, and other processes also which are there. Some of them have the faster rate, and some of them have slower rate. Some of the global drivers, some of them are local drivers. And even in the local perspective, a particular point, the mean sea level, if it is here, the astronomical tide can cause the sea level to rise up to this 1 meter maybe. Then storm surge during that time can cause again rise of this much. Then wave setup means waves in that coastal area cause rise happen up to this, and swash time can cause up to this. So actual mean sea level was here, and together all these processes in the coastal areas that can cause rise of about 2 meter height from that mean sea level itself. If you combine all these factors, astronomical tide, storm surge, means cyclonic time, cyclone, whenever cyclone interrupt or cyclone comes to that place, then wave setup and swash and all other factors. Now, projected contribution to global mean sea level. What is the projections and what are the contributing factors that are counted for these projections? As I have said, oceanic heat uptake means the heat additions to the oceanic water that can cause thermal expansion to happen. That is the primary one important factors. Glaciers that contributing, Greenland ice sheets contributing, means ice placed in the Greenland. I think all of you know about Greenland, location of the Greenland. That is located in Atlantic Ocean, northern part of Atlantic Ocean. You have North America and Europe continent. In between you have Greenland. So Greenland ice sheet and Antarctica, I think all of you know, Antarctic ice sheet has a huge volume of ice present there. Then anthropogenic interventions in water storage on land that also contributes. And as I have said, the contributions of this every year also differently they behave. As I have said, at maximum it can contribute 58 meter Antarctica glaciers, but every year this is contributing 0.3 to 0.6 millimeter per year. Out of this 3.5 millimeter per year, I have told you that this is the amount of rate at which the sea level is changing or rising, out of which Antarctica glacier is contributing 0.3 to 0. Okay, and Greenland glaciers, this also contributing at same volume 0.3 to 0.6. Why this is range? Because sometimes you may have more summer, more heat there, so it can increase to 0.6. Less heat can cause 0.3 millimeter per year. So this is a particularly minimum and maximum level at which every year this area is contributing